Today we're going to be looking at a little demonstration of Cisco's Viral. I'm running version 1.5.145 on my ESXi host. As you can see on the screen here, we are going to be looking at, let's see, 2 routers, 2 switches, 3 servers, and an ASA. What we're going to be looking at today is a configuration of BGP connecting to a provider edge. As you can see here, I have my provider edge 1, which is going to be represented by a cloud services router, and my customer edge, which is going to be represented by the iOS v1. If we come in here and look at a show ver, you'll see in very large letters that we are running a 1000V VXE processor. Over here on the iOS, looks like we will be running version 15.6. That should do. So one of the things about Viral you have to be aware of is that it makes a single interface that's connected to kind of like a flat network. It's its internal communication it uses with the Linux containers. So gigabit Ethernet 1 on the CSR as opposed to the iOS V, it's gigabit 0/0. One of the things you're going to notice about the iOS's is that they are administratively down by default. One of the cool things though, if we look over here, we notice that iOS v1 is connected to our switch, our intermediate switch, via gig 0/1. So if we come over here into interface gig 0/1 and do a no shutdown, this will turn on that particular interface. So if we do a show CDP neighbors, we should see a switch. Our switch is connected to 0/2, as you can see over here on Viral. Over here on the provider edge, we'll see if we can do a show CDP neighbors. And you're going to notice that CDP is not enabled. We come over here and type CDP enable. It doesn't work. We don't have the ability to do CDP at the global level, so how about we try So let's try the interface level. Hey, there you go, CDP enable. So on the CSR, you have to enable CDP on the interface itself, and on an iOS switch router, you can enable CDP globally. So if we do a show CDP neighbor now, it still shows disabled. Well, it's Viral. I guess it can't be perfect, right? Okay, well, I guess we won't worry about that for now. Let's come in here and make kind of a fake network. So our provider edge, gig 0/2 facing us, will have an IP address of 67.0.0.1 with a /31 mask. It says use only /31s on point-to-point because this gets rid of the network address and the broadcast address. So if we do a show IP interface brief now, you'll see that 67.0.0.1 works. And if we do a show IP route, you'll see that we have the 67.0.0.0 on the /31. So if we come back over here to gig 0/2, gig 0/1, we can put an IP address in here of 67.0.0.0 with a mask of 31. Says the same thing about the /31's not working. If we end it and go ping 67.0.0.1, we should, after ARP, get successes. So as you can see here, we have successfully created a link between our provider edge and our customer edge. So we already know it's going to work, but we shall ping it on the other side. As you can see here, we're able to ping 0, not 2, By the way, Control-Shift-6 cancels out of something that we mess up, so there we go. So 0 works, 1 works, and we have our IP connectivity. Now the next part of this is well, how do we provide BGP to the provider? Now the provider themselves, they're going to be running BGP. AT&T, Cox, Verizon, you name it. They're all going to be running BGP, especially if you want to have block-based IP addresses provided to your systems. So in this case of CE1, we will give ourselves, well, technically the internet service provider will provide an IP for us, so 0/2. Say they give us an IP address of, I don't know, 192.0.0.0 with a mask of slash, I don't know, how about 28? Well, you gotta have an IP address in there, not a network. So there we go. So if we do a show IP interface brief now, you're going to notice we have a 192 address and a 67 address. The 67 address, of course, is connected on the point-to-point link between the customer edge and the provider edge. The problem is, the provider edge does not know how to get to these IP addresses on the 192 network. So what we need to do is we need to look at how BGP is configured. So the BGP is the router, BGP, and then an autonomous system number. So we'll give our fake ISP, I don't know, how about 10,000? We'll give ourselves a fake autonomous system of, I don't know, how about 65,534? Not 35. Let's do that. That should work. So now we have 2 separate routers and 2 separate BGP autonomous systems. Now the next thing we need to do is we need to make sure we have our neighbors. So we can specify a neighbor of 67.0.0.0 in remote autonomous system of 65,535. Over on our iOS router, we do a neighbor of 67.0.0.1 with a remote autonomous system of 10,000. So if you do a show IP BGP neighbors, you'll see that we have the for address family IPv4 unicast a session to 67.0.0.1. Now the neighbors statement does give a lot of information, so if we do a show IP BGP summary, this will give us a better understanding of who our neighbors are, if they're active, if they're up, and of course table versions and prefixes. So now our neighbor still doesn't know about our network, the 192 network. Now one of the things you need to remember, especially in BGP, you can only advertise those networks that you have or that you know how to get to, or the NLRI or NRLI, network link reachability information. So if we come in here and do a network statement for the 192.0.0.0, you'll see here that we have to have a mask. This mask, like we said, is a /28. So 255.255.255.240. Once we specify this network, we'll come back over here to the provider edge, show IP route 192.0.0.0, and you notice that we now have a BGP entry to the 192 external network via our customer edge router. One of the reasons why we like to have this here is because, well, ASAs, DMZ servers, anything we want to have directly connected to the internet may have to use BGP in order to provide these blocks of IPs. In this case, you'll notice with the /28, we have a total of 14 usable IPs minus the IP assigned to our customer edge. So the 192.0.0.1, if we want to ping 192.0.0.1, you'll see here that we have a success. So next we're going to come over here. Let's look at the ASA. So I'm going to telnet to the 17,000 port on telnet. One of the easy ways for Viral to work is you can just do a quick telnet session to your Viral workstation. In this case, I have it configured with a static IP. We connect to the console port via telnet, 17,000. We hit open. You'll see here that the Cisco ASA comes up. Now you might want to change the settings of your PuTTY terminal so you can look at it. We have colors and we have font sizes. In this case, we're going to stick with a 14 font size. That way you can see it a little better. Now, one of the things you're going to notice here is that the ASA is connected on show interface IP brief gig 0/0, which is also administratively down. So if we go to gig 0/0, we can do a no shut command. We can provide an IP address of 192.0.0.2 with a mask of /28. And one of the other things we also have to worry about with a Cisco device is the name inf. This basically turns on our zoning for our devices. In this case, you'll see that the name inf is outside or 0 by default. That's the security level. And the reason we have to do this is because in a Cisco ASA, we have to route based on zones. So route outside, we can do 0, 0, and then the address of the gateway. So you'll see here that I'm routing outside. I can ping to 192.0.0.1 and it responds. Now, over here on the provider edge, if we do that show IP route again, you'll see that the 192 network connects over to our customer edge. Now this might not work because ASAs don't usually respond to pings, but we see that it works. So this provider edge will now advertise this 192.0.0.0/28 to the internet. That way, external hosts will have the ability to reach our internal systems. Kind of the DMZ solution. Now, a lot of the times, you'll have sub-interfaces on an ASA that provide the IP addresses of all these DMZ servers. You might want to have a server that is directly on the internet, especially if it has a really good firewall or really good security features. But a lot of the time you'll want to use an ASA or something like that to be able to provide security and access control for those devices. You can even do NATing if you want to. So you can NAT through the security device, or you can just provide security through said device. So once again, we see here that a provider edge can provide BGP, point-to-point connectivity between a customer edge. The customer edge can then advertise a BGP route to its neighbor, as you can see here. When we do a show IP BGP summary, we're going to have a single prefix state. Show IP BGP will also show us that we have a network 192.0.0.0 with a next hop of 67.0.0.0. And it is learned through 65.535, which is, in this case itself, and it's an IGP connection. So it's actually really simple to be able to provide a BGP connection to our internal devices. I mean, seriously, we're looking at 1, 2, well, not even 2, 1, 2, 3 network statements. and you're done. A router, a network, and a neighbor statement. Well, I hope that has been informative. If you have any questions or want to know more, let me know.